Now, periodic properties. What are periodic properties? Periodic properties means these are the properties of elements and which are changing periodically. When you consider a period, when you move from left to right, the property of the elements going on changing. It may be going on decreasing or it may be going on increasing from left to right, and that type of properties are called periodic properties, and they are changing periodically. So that is why they are called periodic property. For example, if you consider the size of the atom continuously going on changing in a period. If you consider ionization energy continuously going on changing. If you consider electron gain energy, it also going on changing. So these are called the periodic properties, and here we have to study four properties of their elements. First one, atomic size, how it changes along a period and in a group. Then we will study about the ionization enthalpy, how it changes along a period and in a group. Similarly, third property, we have to study about electron gain enthalpy, how it changes along a period and in a group. And one property, electronegativity. So these are called the periodic property, and this periodic property we have to study. So before doing their properties, first time you should know what is the meaning of electronegativity, what is the meaning of electron gain enthalpy, what is the meaning of ionization enthalpy. So first time you should know about the definition and how this changes along a period and in a group, that you should know. So first time, the number one periodic property we will study, which is called atomic size or atomic radius. So what is atomic size? Atomic size means the size of the atom. As you know, already we have done about the structure of atom, and in that chapter you have got the structure of atom is spherical. Since it is spherical, and if you want to represent the size, so how to represent the size? So due to spherical structure, the structure you have to represent in terms of radius. What is the radius of the atom? Based on the radius, you will get the idea about the size of the atom. If the radius is small, atom will be small. If the radius is large, the atom is considered as the larger one. So atomic size means, as you know, this is nucleus, and suppose these are the cells, and we consider the third cell is the valence cell for this atom. So what is the distance from the nucleus up to the valence cell? That distance is called atomic radius. I mean, it is the distance from the nucleus to the cell which the last electron enters. I mean, it is the distance from the nucleus to the valence cell. Similarly, this is one of the atom, these are the cells, and consider that it contains fourth cell, then the radius will be from the nucleus to the fourth cell. So as the cell number going on increasing, the radius of the atom also going on increasing, and that is why the size of the atom also going on increasing. So as the atomic radius increases, the size of the atom also increases. Now, although the size of the atom is determined from the radius, but it is very difficult to find out the radius of the atom. There are so many difficulties to determine the radius of the atom. Do you know what are the difficulties to determine the radius? The first one is, atoms are very smaller particle. That is why it is difficult to determine the radius. Secondly, maximum atom do not exist as atom, they always exist as molecule. For example, hydrogen always exists as H2, oxygen always exists as O2, nitrogen always exists as N2. They always exist as molecule. You don't get nitrogen atom, oxygen atom, hydrogen atom in the free state. And that is why, since they do not exist as atom, so how to determine the radius? To determine the radius, the atom should exist. So that is why this is one of the difficulties. Maximum element do not exist as atom, they exist as molecule, and that's why it is difficult to determine the radius. Second point to the difficulties, In the structure of atom, we have got one concept which was called de Broglie concept. De Broglie said that when electrons are moving in an orbit, since electrons are very small particle, I mean microparticle, they cannot move in a straight line like this way, straight path like this way. It always have the wave nature. Already you have got like this, they will move. So that is why when you determine the radius, if you determine the radius from the nucleus up to this point, your radius will be wrong. So that is why if you want to define exactly, it is the distance from the nucleus up to that point where the electron density is maximum, or it is the distance from the nucleus to the point up to which the density of the electron cloud is maximum. Actually the proper definition is like this, because since the electron have the wave nature, so when it moves as wave type, up to that point you have to measure the radius. If you measure the radius up to the cell, then your radius will not be correct. So that is why these are the difficulties to determine the radius of atom, and that is why radius is determined in different way. Radius directly you cannot determine like this way due to these difficulties. Actually radius are determined from the molecule only. For example, hydrogen molecule, H2 molecule. As you know how hydrogen molecule is formed, hydrogen contain one electron, this hydrogen also contain one electron. Sharing takes place. By sharing of electron, they form a bond which is called covalent bond. In the next chapter you will get it about the bonding. So this type of bond is called covalent bond. By sharing of electron it produces the bond. So this bond have a definite amount of length. Actually bond length means nothing, it is the internuclear distance between two atoms. I mean it is the distance from the nucleus of this atom to the nucleus of that atom. That distance is called bond length. So in a molecule every bond contain a definite length which is called the bond length. So first time what you have to do, by doing X-ray study, you can find out the length of the bond which is called covalent bond length. And after determining the length of the bond, just to make half of it. When you make half of it, then you will get the radius of an atom, because you know when two hydrogen atom combine, suppose this is one hydrogen atom, this is one hydrogen atom, this is the nucleus of this hydrogen, this is the nucleus of that hydrogen. What is the distance between these two nucleus? That is called the length of the bond. So this is your bond length. So when you make half of it, then you will get the radius of one atom. And this is the way to find out the radius of an atom. And since we have determined the radius from the covalent bond, that is why this type of radius is called covalent radius. Okay, so covalent radius means nothing, it is the half of bond length. You find out the bond length. For example, by doing X-ray it was found that in case of hydrogen molecule the bond length is 74 picometer. By doing X-ray it was found the length of the bond is 74 picometer. So what should be the radius of hydrogen? Just to divide by 2, you will get 37 picometer. And like this way you can find out the radius of one atom. But suppose a bond is present between hydrogen and chlorine. So hydrogen is small, you know, but chlorine is larger, like this. So this is the length of the bond. Here you cannot do half. First time you determine the length of the bond. After determining the length of the bond, as you know hydrogen radius is 37 suppose. So what is the length of the bond? From that you subtract 37, you will get the radius of the chlorine atom. So if it is homonuclear molecule, I mean if both the atoms are same, then there is no problem, just to make half. But if the atoms are different, one is hydrogen, one is chlorine, and if you want to find out the radius of chlorine from this bond length, then don't do half. So first time you find out the length of the bond. From the length of the bond you subtract the hydrogen radius, you will get the radius of chlorine. And this type of radius is called covalent radius, because we have determined the radius from the covalent bond. So this is the process to find out the radius of atom. But there are so many atoms which cannot form covalent bond. For that purpose we have to use another method. Noble gas cannot form bond. For noble gas also we will use another method. Thank you for today.